you look at the maximum theoretical speed there of 46 gigabits. That's really for a 16 by 16 stream, but with a higher symbol rate, and you know, is probably not something you'll ever see in reality. But that's the theoretical PHY rate for Wi-Fi 7. So the key is that, you know, Wi-Fi 6 only adds the 6 gigahertz. Wi-Fi 7 adds the 6 gigahertz plus all the other features in terms of the symbol rate, maximum channel width, so going from 160 megahertz width to 320. And another set of things for Wi-Fi 7, we add extremely high throughput, so the high data rate, the 4096 QAM symbols, that gets you more bits per second for the same number of streams. The puncture throughput or puncture transmission allows you to ignore someone who's stepping on part of your channel. So before you would either have to back off or shut off part of your channel. So you see where the interference is occurring here on one of the 20 megahertz channels within an 80 megahertz band. By doing puncture transmission, we can recycle the bandwidth on either side of that channel rather than having to back off or just completely cut off half of it. So it allows you to deal with interference much more effectively. And then multi-link operation, more and more you're going to see radios on phones and other devices that can talk on 5 gigahertz and 6 gigahertz at the same time. Aggregate that throughput or maybe use it in redundant fashion as a fallback. So there are different ideas on how to take advantage of that since we have multiple radios calling these devices at both ends. The other thing that the time-sensitive networking was intended to provide better quality of service support for video and voice in particular. That's a feature that's been essentially delayed by the standards bodies. Don't have a time for when that's going to come out, but when you look at it, it looks an awful lot like what ATM looked like back in the 90s, but implementing it slightly differently. So talking about the status of 6 gigahertz, did I jump a slide? No, okay. The rules are different in different parts of the world. So in the US, there's a lot of spectrum added in that 6 gigahertz band. In the EU, it's a much smaller chunk, only about 500 megahertz worth. So they get less channels available. The idea is that within all those bands, or within all those available channels, you're going to see a lot less interference. So that's one of the big benefits by going with 6 gigahertz, is you're going to see fewer incumbents in that space. So if you ever turned on, if you walk the show floor and if you could see all the WLANs, like if you're trying to join an SSID, there's so many, and most of them are just stepping on each other, particularly in 2.4 gigahertz. So in 6 gigahertz, it's a much more open landscape, and you should see less interference. But I mentioned the word incumbents earlier. There are incumbents in that space, whether they're terrestrial shots or satellite links in that frequency band. So we have to navigate that without interfering with them. And within the different frequency, or the channels within the 6 gigahertz band that's been freed up, there are different rules within each of these different units. So they, in Wi-Fi 5.6, there was a hard limit. You had this power level you could go to. In 6 gigahertz, they changed that a little bit with the power per, it's basically decibels per megahertz. So the wider your channel gets, you can have more power, but then it also limits you in some ways. And there is this notion of standard power, which has the max of 36 milliwatts, or 36 milliwatts, and low power, which is 6 decibels below that. The idea is that by operating low power, you're not going to interfere with somebody who's in the same area as you. So remember I mentioned those incumbent users in the 6 gigahertz space. If you're at low power levels, you're not going to interfere with them, but at standard power, you might. So there's this notion of the AFC controller. So you see where standard power is mentioned, AFC control. So you have to coordinate with the AFC to get permission to transmit on those frequencies. So those channels are not available at standard power if you're in that space. Now, with low power, you can operate on any of these, but you notice that the Uni 6 and Uni 8 bands, you cannot do standard power. And again, the rules for, oh, there it is, 36 decibels for the maximum power level at standard. The power level, the power spectral density varies based on how wide your channel is, and which bands you're in. And the rules are different for the EU than for other countries. Not all countries have approved Wi-Fi in the 6 gigahertz band. The other thing is that the clients are always operating at 6 dB below the AP. So if your AP is reduced in power because you can't communicate with the AFC, it's going to be dropped 6 decibels. Your client is going to be 6 decibels below that. So now you're cutting your power quite a bit, effectively from where you might have been used to dealing in the Wi-Fi 6 or Wi-Fi 5 power levels. And the reason, I mentioned the incumbents and using the AFC, the rules for low power indoor, that's basically the catch-all. So if you can't communicate with the AFC, you have to do low power indoor, at least to do it legally. If you are going outdoors, you absolutely have to do standard power. So you have to coordinate with the AFC, where you're telling it, here's my position, here's the channel I want, here's my elevation, I'd like to communicate at standard power. They will give you an up or down response, and if you are not approved, then you just have to look for a different channel. And the reason why this is important is because the incumbents look like this. So chances are there might be somebody nearby, particularly in the heavily populated areas, that you need to worry about. We're doing a project with some folks from Notre Dame who want to look at, just how well does this work, because one of their participants was involved in the standards, and they want to see, okay, well, at standard power, how far do I have to be out in order to, not be seen at all by this incumbent? They have a line of sight shot that they're really interested in. So there's still some areas where the effectiveness of the standards is being, discovered. We're still in the process of learning a few things here, but in the ability to coordinate with the AFC, that's something that allows you to start off at low power, and then once you communicate to the AFC, and you can do that, like with our system, you can either use a mobile phone to register the location of your access points, or if they have GPS, they can use that as well. It gets relayed back to the controller, and then for devices that don't have GPS, you can use 802.11mc relative distance measurements so that you get a very effective measurement of where they are, because that's the thing, you have to be in a specific location in order for the AFC to give the proper answer. And so it's all about not interfering with someone else and them not interfering with you. So those coordinates are sent to the controller communicates to the AFC, proxy in our case. We actually work through ComSearch, which is a sister company within CommScope, and then they run the database, and they're licensed or approved by the FCC to be an AFC. So the service communicates the details to CommSearch or whoever your AFC is, and they give you a response which ultimately determine whether you can go to standard power, which will increase the size of your cells around the APs, for your coverage. Initially you're going to start out with smaller area coverage until you get elevated to standard power. Now, when you look at coverage from what you're used to seeing in 5 gigahertz to 6 gigahertz, the higher frequency doesn't penetrate as far. It suffers a little higher free space path loss. So you might have the same access point transmitting at full power at 5 megahertz or 5 gigahertz and see pretty different coverage from the same AP operating at 6 gigahertz. Now in this case, it's full power 5 gigahertz versus 6 gigahertz at low power. So, but as you can see, this is the same footprint, same AP, the channel, the coverage looks quite a bit different. And so you may not see that big a difference, or this big a difference in your environment. It depends a lot on how much attenuation you're getting from the walls and the other obstacles in the way. But it's certainly something that if you're adding 6 gigahertz into your network, you'll want to think about doing a Wi-Fi redesign. In other words, a whole new coverage plan, just to make sure that you don't run into a situation where the coverage is good for 5 gigahertz, but there's big gaps in between APs in the 6 gigahertz range. That's your biggest concern, because you don't want users dropping service as they're moving through, roaming themselves. So one of the important things that we learned along the way is that not all clients are created equal, and your clients are going to drive a lot of what happens in your design and how you implement. So there are clients that are low power indoor only, and there is a place within the FCC, and the link will build out eventually here, where you can find out what the status of your client is, if you happen to have a particular client or clients that you're serving. But a dual client can do low power and standard power. Now the big thing about this is that when a low power only client sees a beacon from a standard power AP, it ignores it. So you won't even see, like when your phone, if your phone is a low power indoor only client and you're looking for a WLAN, you won't even see it on the list, even though it's broadcasting around you, because one is operating at low power, one is operating at standard power. And that's something that, if you have clients that particularly only can do low power, that's going to be an important consideration for you, because it's going to change what your coverage looks like and what your clients do. Because the weak link is always your client transmitting back to the AP, because they don't have the power. Batteries have gotten better with the newer phones, but they're not going to compete with what the AP can do in the other direction. And then remember, the client is always 6 decibels below the AP. And so the link here gives you the ability to look for, search the FCC database to find out what the status of your either client or APs. You can search for both to find out which ones have been authorized for standard power versus low power. So we're probably almost done. The presentation is available on file. There's a lot of information in here that I didn't get a chance to cover, but for those of you who came in late, definitely check that and come to booth 710, because we can talk further there. For the clients to discover what WLANs are available, in 2.4 and 5 gigahertz, we do beacons and probe requests and probe responses, and each client talks to each AP to find out what's available. Now, in 6 gigahertz, there's a couple of ways for a client to discover what SSIDs or what WLANs are transmitting. One is via reduced neighbor reports. So you could learn from an AP that's part of the network, but transmitting on 5 gigahertz about a channel that's on 6 gigahertz for the same WLAN, or maybe another WLAN that you're interested in. And so that's one way, and there's certain client vendors that kind of preferred this. They want to see you using a WLAN in 5 gigahertz and 6 in order to make that transition easy. And so this is one way to find out, and it works a little differently because the beacon frame actually has other information elements that point to those other networks. And the other thing is that in band, you can scan all the channels, but as it says here, there's a lot of channels to get through. That takes a long time. And if you are in a channel, particularly a 40 megahertz channel, that doesn't line up with one of those preferred scanning channels, those ones in yellow or orange, that's where the clients can look in those channels, and that's where they're designed to look only, so that they don't have to scan all 59. If you get in a 40 megahertz channel and you're not lining up with that, you're not going to find out about those beacons, particularly multi BSSID beacons, where you can find out all the other WLANs that are on there. Now, that's something that we do in 6 gigahertz, and you're going to see a different SSID being broadcast, and that's where your multi BSSID beacons reside, and those are going to tell you about all the other WLANs, the names of what's transmitting, and then what channel they're on. And so it's a pointer to go somewhere else to find the network that you're looking for. And so this was something that was put together by one of our SEs. It kind of gives you the mapping of all the different channels, and based on 20 megahertz, 40, 80, 160 through 20, and then the center frequencies. It's a good reference. So definitely pull that out of the presentation file. Now, WPA3, 6 gigahertz requires WPA3 only. You cannot do WPA2. You can't do the old pre-shared key. So you have to support WPA3. This is going to create transitional kind of problems for some people, because you're going to have some clients that can't do that and some that can. And so what you're probably going to end up doing in most cases is setting up an SSID that is WPA3 only, and then another one that parallels that. It's more of a legacy one that allows the transitional mode between WPA2 and WPA3. So if your clients can't support WPA3, they can participate in that one. And then over time, what you're going to do is keep track of how many clients are stuck in that older legacy one where you're doing WPA2, because ultimately, we're going to be mandated to kill that. So you want to know how many clients you're going to hurt when that mandate comes along, and try to drive your clients over to WPA3 support. So this is another thing that, in order to figure out who's going to see what and who's going to be able to roam between 5 and 6 gigahertz, there's some things that you have to keep track of or consider. And so that's why I think that you're having a legacy WLAN and a newer WPA3 only WLAN that can cross all 3 bands makes a lot of sense. So, wrapping it up, you definitely want to use more than 40 megahertz channels within the 6 gigahertz, just to make sure that you're lining up with the the preferred scanning channels. And then you'll also want to use reduced neighbor reports, because not all clients will do the scanning at 6 gigahertz to find what WLANs are available. So most of, I know that we default to 80 megahertz, and that will vary vendor to vendor. So it's something that you want to keep an eye on, that you're not picking 40 megahertz channels and then putting yourself in a situation where you can't see, clients can't see the WLANs you're trying to join. WPA3 versus 2, again, probably a legacy versus WPA3 only. And then your clients, are your clients low power only, or are they dual capability so that they can work with both? Because if you have low power only clients, you don't want to be transmitting standard power and expecting them to be able to join those WLANs. And that is 20 minutes. And I know that we have somebody coming in at 11 o'clock, so I don't really have a lot of time for questions here and now. But if you want to talk in the hall, if you want to talk at booth 710, we will be there throughout. So I appreciate you all, your time and attention and your interest, and that is all. So.